Hello guys. So today we'll be solving the question MinStack on Leetcode, and this questions is similar to the implementation of a stack. So it will implement the method of a stack like push, pop, top, that is similar to peak. And this question is interesting because of this method get minimum. So this is the interesting part. So I'll suggest you guys that if you guys have already tried this question on your own, then it will be very helpful for you. Otherwise, it will be difficulty. So I want to make it clear. So uh, let's get into this video. So if you guys already know what is a stack, so a stack is like a container. If we try to implement any, let's say contain an element here, then the next element will be inserted over there, and the next element will be inserted over the top of previous element. So and so forth, it will be inserted. The element will push into this stack. If you want to pop the element, the last element that you have inserted, the last element you have inserted, the last element you have inserted, that element will be popped out from this stack. So this is a very basic rule, basic operation, or basic process of this stack. Okay. So in this question, so if you look at this, so it's saying that push the element, uh, pushes the value onto the stack, then we will pop the element, then we will get the top element of the stack. Top means uh, whichever element is on the top, we will just show it, we will not remove that, and get a minimum. So we will get the minimum element among all the stored element from that stack. Okay. So let's say if you want to uh, uh, store element, let's say it's the first element is mm, 2. Let's say 2 element you have stored. Okay. So what is if I ask you what is the minimum element of this stack, so you will tell that 2 is the minimum element because it's a single element now in this stack. Okay. So let's say if we add another element in this stack, so add another element, and let's say we'll add 3 over there. So if we when we add 3 element over there, so now tell me which element is the minimum. So the minimum element is still 2, right? Let's say insert a new element, and we will insert a new element called 4. Okay. So which is the minimum element? Still 2, right? Let's add one element. Now the minimum element will be 1. All right. Now again add element. So let's say this time we will be adding -1. Okay. So -1 will be the minimum element, right? So like that. So if I ask you, so which is the minimum element, you will say -1 is the minimum element, right? So every time when you are pushing the element into the stack, we are updating the minimum element, right? Now what is the issue in this question? The main problem, or more the main interesting thing happens in this question is things happens in this question is when we deal with the get minimum. I'll tell you how. Let's say if you want to pop a new element, let's say if you uh, let's say you want to let's say you want to pop a new element. Okay. Not you want to pop element from this stack, so we know that the first element will be inserted, first will be element will be deleted or will get out from this stack. Okay. So if you deleted this element, so we already knew that -1 was the smallest or minimum element or minimum value in that stack. Okay. So when you deleted it, right, when you deleted the minimum element, what happened? So when we will whenever we will pop out the first element, we know that the minimum element, which was -1 in this case, okay, so it's popped out, it is popped out from this stack. correct? So that means what? If the minimum element has popped out from this stack, so what happened? This was our minus. Now if I ask you what is the minimum element of this stack, then your answer should be 1, right? Your answer should be 1. Okay, let's remove it. Let's remove 1 as well. Okay, and your minimum 1 element has removed. Now if I again ask you what is the minimum element of this element, this stack, so then you will say, so the minimum element. Okay, so what can you do to get the minimum element from this stack in omega 1 complexity? Because we know that this question is already saying that implement a solution with omega 1 time complexity for each function. Like at once the function should work, like at the omega 1 push should work. For omega 1 pop, the element should be removed, and in omega 1 we should be able to pick the topmost element, and in omega 1 we should get the minimum element, right? So if I ask you to get the minimum element from this array, one solution is that you will iterate you will iterate all the element one by one in this stack. You'll first go here, then here, then here. Like maybe see, like you can store this stack using array list or in array, or in node list also, right? In either way you can implement. So if you try to implement this, you have to go each time and look for minimum element, and then you have to filter out the minimum element, which is 2, right? So if the element size is total n here, so what is the time complexity, worst time complexity, to get the minimum element, to get the 2 which is minimum? So it's omega n. So we should not, we don't want that solution, right? So what is the solution, what can we do? So for that, let me we will be implementing through a node, and let me clear this uh, drawing, and I'll show you what to do it. Okay, so all right. So see, so what we'll do, we will create a node class. Okay, in node class we will be, there will be in that node class we will store 3 elements. Okay, one will be the value of this node, like whichever stack you want to use. Let's say let me draw let me draw institutions here. Let's say first we added 2, then we added 3. Okay, then we added 3, then we added uh, -1, then we added 1, then we added 5. Okay, so mm, so perfect. Okay, so first element added 2, right? So what we'll do, so first element we will add over here is 2. Okay, then we will add a minimum element. What will be the minimum element? So if this is the first element, no, this means what? If this is the first element, uh, we will be store 2 as a minimum element. See, because if the first element will always a minimum, right? And the third cell of this node we will store node. So we will for now we will store null in this, right? i'll I'll explain it. So I'll explain it. Okay, so null. Okay, good, fine. And we will call this as a head. Okay, this element will be called as head. All right, now when 2 has been added, now let's go to the another add another element called 3. 2 is already added, now let's go to add 3. So we will create a new node. We will create a new node, and what will happen in this new node? We will first add 3, right? 3 value. Okay, let me change the color as well. Let's say, okay, 3 is added here, 2 is added. Okay, 2 is added, 3 is added in this stack from this. Okay, so 3 has been added. So we will create a node. In this node, there is total 3 cell we have created. In the first cell we will add the value. In the second cell we will add the minimum. So we will compare what? We will compare minimum value. What is the minimum? Minimum value? This is 2, right? So this 2 will be compared to this 3. Okay, compare, right? We will compare it. Compare. So we will compare. So which will be the minimum? 2 will be the minimum, right? So we will simply add 2. Let me write minimum element in green color. Okay, and now what we will do in this we know that this last node, third node, will be stored in node, right? It will point to a next node. So this node will point to a this node. Okay, point to this node, and we will delete this head, uh, and we will be make this new node as a head node. Okay, we don't want to uh, store the reference of the first node. Okay, we don't need it. So we will be update the head node. Now let's again create a new node, and in this new node, again 3 cell, we will be implementing -1 as a value in this cell, and in the second cell we will add a minimum so far. So how? So we will be again compare this -1 with the minimum value of this. Okay, so -1 and 2, which is the minimum element? -1, right? So -1 is the what? Minimum element, correct? -1 will be the minimum element, right? And we will point this node to a previous head node, and after that we will update the head node. Okay, so this will be head now. Okay, now again create a new node, because again we want to implement a again we want to add a new element. So in this case, what we'll do, we will be creating a new node. Okay, and in this new node also 3 cell will be there. We will add a value, and the value is 1, right? So value is 1. So -1 is already added. Now we are adding 1, right? So 1 is added, and now in the second cell, which will store minimum so far, in the so far minimum element in this stack or in this node. Okay, so again we will compare the minimum element of previous node, that is head node, and minimum element of this new node. Which is the minimum? -1. All right, so let's add -1 as a minimum. So still -1 will be minimum. Okay, and we will be point this next point the this node to the we will point the next node of this node to the head of the node. Okay, and then we will be update the head. Okay, will be update the head. This, that means this new node will become a head node. Okay, now again what we have to do, we add the fifth element. Okay, so again if you want to add the fifth element, this new node will be created. All right, and 3 cell will be made, and I will also write the code for this also. Okay, and what we'll do, we will add a element 5 in this. All right, and then we will be compare the minimum element. So we'll compare the value of this node to the previous minimum. Okay, this is the previous minimum. All right, so -1 is the previous element. So we'll get -1 as a previous, -1 as a minimum element, right? And we will, the next node of this node will point to the head, that means previous node. Okay, and we will update the head node. All right, so we'll update the head node, so this new node will become a head, right? Now what will happen, let's say I'll ask you what is the minimum element. So you'll simply say the minimum of head is -1, right? See, in this stack the -1 is the minimum element, right? Now let's remove it, pop it. So if you want to pop this element, how we will pop it, we'll simply say head next will update to head. This means what is the head, this, which node is the head? So we'll say this node is the head, right? And the next of this node, the next of this head node will become head. So the next of this head node is what? This node, right? So we will simply update. So we will update head node, and the new node will be this one. This will be the head node, right? And this will be deleted, right? Okay, again if I ask you what is the top element, you will say the top of head, the top of head, the top of head is what? 1, value is 1. Okay, so 5 has already deleted. Now the stack is like this, stack is like this now, right? 5 has been already deleted. So the head of value is 1, the head of minimum is -1, right? So it's work like this, like in every node we have compared the minimum, and every node has already contained the minimum element so far. Okay, so this is the uh, basic funda of these questions. If you have understood it, that means you have got the questions, right? You have killed these questions. So that's it. So let's remove the element. So let's remove, let's perform a pop operation. So pop operation will be what? We will be saying the next of what we'll do is simply say the head, the next of this head will become, make the head of this next of this node. Okay, wait, okay, so I'm saying, what if we try to perform a pop operation, we'll simply say that the next of this head node will update to a head node. Okay, so again I'm repeating. So the next node of this head node, what is the next node of this head node? So the next node of this head node is pointing to a this node, right? So I'm saying that make this node as a head node. Okay, make this node as a head node. So we will be head next will become head. Okay, the next of head will become head, and will simply, this node will simply be dereference. It will no longer be accessed. Okay, now again if I ask what is the minimum element, so in omega 1 time complexity you are able to know the what is the minimum element, that is -1 still. Let's remove it, let's pop out it to pop out. Okay, and this will become your head node, right? If I ask you what is the minimum element, you'll say 2. So right, what is the minimum element? 2. If I ask you what is the uh, pop, like if I ask you to perform a pop operation, that means what is the topmost element? So what you will say, you will simply say the the top element is what? The top element is 3, right? This top element is 3, right? This is 3. And what is the minimum element? The minimum element is 2, right? So like that, if I want to remove it, let's remove it. And okay, remove this, and this will become head. All right. So this last element is again called as head, right? And again, if I want to remove it, so we'll simply before that, if I want to know what is the value is 2. What is the minimum element? This only 2 is left, right? So 3 has also gone, so only 2 is left. We'll say 2 is there. 2 uh, is a only element and 2 is a minimum element. Okay, if I ask you to perform a pop operation on it, so what we'll do, we'll simply say that you simply take that head next, the next element of this will be null, so we'll simply make this head as a null, right? All right. So this head will become, this head node itself will become as null, right? So like, so no node is left, right? So this two has already, this two already gone. Now this stack is empty. Okay, now let's do one thing. Let's write the code. Okay, so you guys can check over here that it's saying that minimum push, like, if you guys already know, like it will just push -2, then push 0, then push -3, then want to try to get minimum element, this will, that will be -3. The output over here is now again pop. So if you pop, this pop means it will, in their test case, it will return null, because top is not returning anything, right? Get the top element of the stack. In the method, it will return integer value. uh, Here it will just simply say that uh, it is null because this field is empty, right? So no use of it. Now if you want to get a top element, so top element is 0 and get minimum is still -2. So pop is like, it's just returning nothing, right? It just remove it. Okay, so let's get and write the code. Okay, so we will we will write a node class first. Okay, let's write an inner node class. We will be store data. Okay, then we'll store minimum value, then we'll store a node which will be next. Okay, and this will be your node constructor, node parameter, and we will also make a node constructor with 3 parameter. First will be your the value which will be inserted when the new node will be created. We'll insert a new value. Also we will be inserting what, we will be inserting a new minimum value. Okay, and then we will be inserting a node. Okay, okay, so the type of this node will be of node class. All right, so let's the data of the data variable of this class will store value which is being passed, and similarly for data of minimum value of integer will store minimum element, the parameter, and this node simply point to next, this next of this node. All right, so let's write a code for push method. Okay, so in each case, like in first, whenever a head will be null, right? First time head will be null, right? So let's write a node which will slice null first. Okay, so this head will be null. If this head, if your head is null, okay, this means what we will do when your head is null, we will simply do one thing. We will create a new node. We'll create a first node. So that first node will insert take a value. Then also the first, this is a first element, right? The minimum element will also be a same value, right? And in first node we will be inserting null. All right, and assign this new node a head node. Okay, so what happens? So first node will be created. Okay, and data will be stored, minimum value will be stored, and this new node, okay, this new node will become null. Why null? uh, Sorry, I did it wrong. So this will be your node and this will be your next. Okay, all right. So whenever this null is passed in this constructor, okay, so the next variable of type node will store null. Okay, so node is nothing but a null when your head is null. Okay, otherwise else what happen? No issue. We will simply create a new node. Okay, add a value, then we will add a minimum value. So minimum value for what? We will simply say we'll compare the minimum value, which will take input your current value and your previous minimum. So previous minimum is what? Your head. So your head is head minimum will be your previous minimum, and we'll be uh, we will simply add a new that previous node head. Okay, and we'll update this node as a head node. So what happened over here? Your value has been asked, your value has been passed, and you compare the minimum element from your current value and your previous head, right? So what was your previous element? Like if it's 2, then minimum element is also 2, and next node was null, right? So 2 and 2, like if your current element is 3 and previous head minimum was 2, then it will return this minimum method will return 2, and this head is what? This head is a previous head, right? So this previous head is also passed, so it will go over here, node is head. So this dot next is a simply ops concept. Like if you, this dot next is a new node, right? This is a new node, right? So new, the next of this new node is what? Head. So I'm again repeating, when you pass head, it will go over here, and this head will be initialized by next of this newly created node. Okay, and we will update this head node. Okay, so I have already explained you guys. Okay, so now let's go for pop elements. For pop element, what we'll do, we'll simply just pop up. We'll simply say that we'll simply update. So head will become head next, right? So head next is head now. So that's pop. Now if you want to look at a top element, we'll simply say head dot what was the name? This was data, right? So head dot data is a top element, and we will return it. And if you want to get a minimum in omega 1 time complexity will also say the head minimum is a minimum element so far, because it is keep tracking of the minimum element. Okay, so simply say head minimum. All right, and we'll return this. All right, let me run it. Let's see if there is any comparison error is there or not. Okay, so line 10 compilation error node. Okay, let's send well. Okay, silly mistakes. Okay, and line number 10, that's it. Okay, let me run it. Again, mean stack node cannot be converted to boolean. Okay. So if it is number 22, okay, if it is equal to all right, now let me submit it. Okay, so it's accepted. So it took 4 milliseconds. So that's quite impressive. Okay, so that's for it, guys. I know that that video has been longer now, but I actually wanted to show you a detailed view of this very important questions. And so for that, I took a chance and uh, I actually tried to uh, explain it. So that's for it today. Thank you for watching.